Good morning. My today's talk is Dependency Chapter. Short introduction. If you want to learn more about me, find me on GitHub or Twitter. These are my handles. The reason I chose this talk to talk about this dependency trap is I can see in the community quite a big interest in things like domain-driven design, quite a huge and heavy stuff. And I have a feeling that people are forgetting more basic principles. So I just thought it's good to remind them, refresh them a little bit. So I'm going to describe the problem based on a crawler. We will write a crawler that fetches some DOM document, extracts some details of that document, and then, saves that to database, for example. OK? So I don't want to reinvent the wheel, so I'll use a third-party library for that. Buzz is like an HTTP client. Lightweight, very simple interface. Provides adapters for different types of connections. You can use curl, you can use file-get contents, all that stuff. So it looks very good. It's very simple. I'll just add it to Composer and install it. My remote stopped working. So this is how it might look like. Package crawler, and I use dependency injection. I know how to do that. Right, so just inject it in a constructor and then use it. Code looks great, life is beautiful. Then obviously, after fetching the response, I'm going to do something about it. Okay, that's actually core of this class. I thought I'm doing the right thing because I reused third-party library. I didn't try to reinvent the wheel. I used dependency injection. That's great, right? But what I actually did is that my crawler directly depends on that third-party library. Okay? And in the project, I probably have more crawlers. And all of them depend on the same library. It's fine until we decide to replace it. Okay? So Buzz was fine, light, did what it was supposed to do in the beginning, but then project evolved. We need more features, and Buzz might not be the best tool for the job anymore. Okay, we might look at tools like Guzzle, for example. Might think, okay, we need to cache those responses. Buzz doesn't support it, but Guzzle does. Okay, and that's how we actually fall into a trap. Because we made all those crawlers depending on the Buzz browser. So as a result, if we want to change the Buzz browser, we need to change all the crawlers. All our code is affected. If there's a bug in the Buzz browser, all our crawlers are affected. Okay, we introduced coupling, quite high coupling. Yeah, the definition by Fowler says modules are coupled if changing one of them requires another one, changing another one. It's not that we can avoid coupling. It's not that exists or not, but we can move towards tight coupling or more loose coupling. Okay, tight coupling where everyone knows everything about each other. Loose coupling where we have nicely defined interfaces that, well, packages talk to each other, modules talk to each other through nicely defined interfaces. So, when coupling actually increases, we have a few scenarios. First of all, we introduce coupling when we introduce a variable that stores a reference to another class. So if our crawler class has a reference to the browser, we introduce coupling to the browser class. Simple as that. Also, if we call methods on the other class, if I crawler calls methods on the browser, it might not necessarily use it directly, but through such a violation of law of the meta, right? Train wreck. We just access the browser through another object That's also coupling to the browser. Third case is when we reference a class in a method. Okay, it might be a method signature like this, method argument. It might be a return value as well. Okay, that's also when the coupling increases. And then, obviously, when we extend another class, we introduce coupling to that class. So you might think, why bother? And let's just do it ourselves. I don't want to use any, if that's that complicated, I don't want to use any third-party library, so I'll just use curl and get the job done. Okay? But then we're violating another rule, or we fighting with another force, cohesion, okay, which describes how closely are modules related to each other. Okay, in the previous example, the thing that we use curl to fetch something from a site has nothing to do with parsing that content, DOM document. Okay, that's two distinct responsibilities: fetching DOM document and then handling that. So cohesion is actually another way of describing single responsibility principle from solid principles. Okay, modules should have one reason to change. In the previous example, when we use curl directly, there's more than one reason to change. Okay, what if we want to suddenly read a file from a file system instead of the site directly? What if we want to read it from the database? It needs to change. And then, if document structure changes, our code also needs to change. Okay, there's more reasons for that class to change. So the idea is to gather together the things that change together. Okay, what we put in that method, that's on a multiple levels. You can look at it at the method level, at the class level, the package level, component level, right? We gather together things that don't change together. Simple violation like that. And usually when we introduce tight coupling, when our modules are closely related to each other, that means that they have also low cohesion. They're also doing more than one thing, right? And vice versa. Loose coupling leads usually to high cohesion. So nicely defined interfaces between modules make that those modules are quite independent. OK, I've been talking about it for 10 minutes now. So how was the solution? Okay, how to introduce loose coupling, actually. And the principle is very simple. Dependency inversion principle, another principle from solid principles. Okay, what we did initially was this: package crawler directly depends on the bus browser. And the dependency inversion principle says a few things. First is that high-level modules should not depend on low-level modules. Our package crawler is a high-level module. Okay, you can describe it what it actually does on a high level with a high-level language. It should get content, extract metadata, put it into the database, or store it somewhere. Maybe not the database. While bus browser, that's a low-level module, okay, for making HTTP connections. Very specific low-level thing. So the principle gives us solution. It says both high-level modules and low-level modules should depend on abstractions. Okay, so watch the bus browser. We introduce abstraction. Okay, so I say, okay, my package crawler is not going to depend on the bus browser directly. It's going to depend on an interface, HTTP client interface. HTTP client is some kind of an abstraction. Okay, the principle says both should depend on the abstraction, so also our bus browser should implement that interface. Okay, but I actually made a small mistake here, but the principle clarifies that. abstractions should not depend on details. By giving the HTTP client that name, I actually suggested the solution, suggested the implementation. HTTP client is something very specific for the Buzz browser, for example. So that means my package crawler actually doesn't care if that's fetched from HTTP or from a file system, from a database. What it actually needs is to load a DOM document. And giving that interface a name, HTTP client, I'm suggesting that it's actually gonna always be like fetched from a site. So that limits the amount of changes I can actually make to that design. What the principle clarifies again, details should depend on the abstractions. Okay, so instead of giving the interface a name HTTP client, I could call it, for example, content provider. It doesn't say anything about the solution. It says more about package crawler. And that's the main thing about those interfaces. They more belong to the package crawler rather than the Buzz browser that implements that interface. Okay? If I would store it in a package, I would store that interface together with a package crawler, not with the class that implements it. Excuse me. So it's always considered in the context when it's used. If you wanted to implement it, this is how the interface looks like in PHP, in case you didn't know. So we define a method. The interface name and the method name are both should reflect our needs, not satisfy the class that's going to actually implement an interface. And our crawler is going to depend on that interface and use it to fetch content. So nothing about Buzz, nothing about Guzzle or anything else. We have a content provider. So it looks like this. All our crawlers depend on that interface. So the other part of the story, we implement that interface, simply decorating the browser. That's actually an adapter. We adapt Buzz browser interface to our domain interface, I would say. So simply call browser, decorate browser in this case. So then our Buzz content provider implements the interface and it uses Buzz browser. Notice the dependencies. There's no direct dependencies from the crawler to Buzz browser. Okay, so if Buzz browser changes, think about it, which class needs to change? There's only a single class, Buzz content provider. Okay, if there's a bug in the Buzz browser, we need to implement a workaround. We only need to touch one class. All of our crawlers are not affected by that change. And also, if you want to replace Buzz with Guzzle, we just implement a new adapter, implement the content provider interface again. Notice that using Guzzle might be more complex than Buzz. We don't care. Our clients still rely on a single fetch method. Okay? Whatever needs to be done to conform to that interface is done here. So anything Guzzle specific is here, nowhere else. Right? So we implement the Guzzle content provider, and that's going to use Guzzle and can be injected instead of Buzz content provider into the crawlers. So actually, the blue and purple squares are third-party libraries. Green is ours. Also, our adapters, that they belong to us. But they might be implemented in a separate package, actually. So why is tight coupling bad? Or to ask a more positive question, why is loose coupling good? Summarize the whole example. So there are three functions of a module. First of all, it needs to be useful. It needs to do its thing, the thing it was designed for to do, right? If it doesn't work, it's useless. Second of all, it needs to be ready for change. Okay? We need to be, it needs to react to changes to requirements. And then it also needs to communicate to its readers. It needs to be readable, right? So the coupled code is like that. It's easier to read and understand. You don't have all that low-level details of using Guzzle in your crawler. You have a simple call to some kind of a content repository. All of your calls are on the same level of abstraction, let's say. So it's much easier to read and understand. There might be more classes, but that doesn't mean it's easier to understand, because it doesn't mean it's harder to understand, because you actually can understand them in separation. It's easier to reuse, because I could reuse the same crawlers in a different context with different implementations of the repository, content provider, sorry. Therefore, it's also, for both of the first two reasons, it's easier to maintain. But the most important thing is that it's easier to change it. I show you that. I replaced Buzz with Guzzle with no problems. Okay? And that's the main thing. We need to enable change. Because change is the only constant in projects. Okay? There's always going to be changes. You can't predict everything. Often developers get very angry when manager comes to them. Okay, we need to change that. No, that's going to break my design. It was so beautiful. Right? If your design cannot handle changes, then it's a wrong design. Okay. What else? It helps us to actually defer decisions. I actually had this situation before. I actually chose Buzz because at the time it was a more mature project than Guzzle. Guzzle was just starting. And a few years later, it occurred that actually it wasn't a good decision because Guzzle offers much more features I could use. Okay. Follow this approach, I would be able to change. Okay, I don't have to commit to the decisions I make, because everyone knows in the beginning of the project that's the worst point in time where you can make decisions. Okay, you learn through the project. So by doing what I shown in the beginning, using Buzz directly, or third-party the library directly, we kind of commit to using it till end of the project. In the beginning, okay, there's no way back. There's no easy way back. So this is a Symfony framework conference. So how does it relate to a framework? Just to let you think a bit. This is a standard controller. We see blog posts, documentations. Now, the pretty standard thing for Symfony. Sorry. If you could count dependencies in this controller. Sorry. Got request. On request, we've got a parameter bark, like query. We've got a render method, which is actually dependency on the templating engine from Symfony. That's a hidden call to a service. And then we also have a dependency on doctrine, and then one of its repositories. And actually, there's a lot more that you don't see here. Extended controller brings a lot of dependencies, potential dependencies in there. Okay, you have access to the whole container. Those green ones, those green boxes are actually okay, because the controller is your transport layer. It's actually fine to use those classes in there. That's the right place to use the framework. The red ones, not so much. That's the Buzz story again. We use doctrine directly. What if we want to change it? What if we want to change from a database to an API? Okay. There's few solutions for that. It's actually there's few models describing how to solve it. Or actually, we're talking about more or less the same thing, just from a different perspective, like layered architecture from domain-driven design. Now divide your application into layers, and each of the layers can only talk to the layers below. What I like better is the clean architecture model. It better illustrates how dependencies go, because all those internal circles, they cannot talk to anyone, right? Entities cannot talk to anyone. Use cases can talk to entities. So dependencies go inwards. Okay, so we have entities, use cases, controllers, and stuff. Outside, there's things like database, like HTTP clients, all that implementation details. Okay. So nothing can directly talk to that. If you want to talk to your database, you need to use dependency inversion. Okay. So source code dependencies can only point inwards. And then it's very similar to hexagonal architecture or ports and adapters. We heard about it last year in a talk by Konstantin and Marcelo. Again, our application is in a center, and it provides ports. Okay, it might provide user interface port, data port. We might then implement adapters for that. So to access data, doctrine, or for example, in memory. Okay, they're pluggable. You can replace them easily. So your tests could run in memory while real implementation uses doctrine. Similar thing with the user side. We might have a separate interfaces to exercise UI in tests, or our application tests, actually, command line or the web page. Right, so it basically says we should create our application the way that it works without the UI or the database. How to fix it? How to fix the previous controller? Just a little bit, not full time. First of all, I think it's good to make dependencies explicit. Okay? So inject them in your constructor. That's the best way. Notice we're not extending anything. Okay, it's already quite a big improvement. So I inject the templating and doctrine for now. And then simply, instead of accessing that from a container which is no longer there, I just use it. It's much clearer what happens. And then we actually, looking at this, doctrine is still not in the right place. Okay, we actually need a repository. So why not simply replacing this with a product repository? That's what we need in there. Okay, we don't need the whole doctrine thing. And then use repository. But still, that's a doctrine repository. And that's like talking to infrastructure directly. So, whoops. What we can do is to, again, break the dependencies, introduce a product repository interface that's going to describe our repository. And it doesn't belong to doctrine, it belongs to us. It's in our model or domain layer. Then we depend on that repository instead of doctrine. Doctrine is going to implement it, but that's a detail. This way you can easily replace it with some other kind, with Elasticsearch or whatever. So it looks like this. Our search controller uses product repository, which is an interface, and doctrine is going to implement it. Right, so this our repository is going to use doctrine repository to implement this thing. So as mentioned before, changes are the only constant. But the bad news is that we actually cannot predict every change, and we will make mistakes. Okay, but I think it matters what you do when that change comes, and you cannot easily introduce it. Okay, do you make a hack? Add another if statement, or you change the design? So we cannot prepare for every change either. That means, well, if you try to prepare for every change, you would be introducing abstractions and interfaces everywhere. And it would just make the model unreadable. Right? You need to make a decision. What do you think? How that model is going to change? How likely it is to change in certain points? Because premature abstraction is also evil. Okay? You often cannot start with an abstraction because you don't know the project well. You often need to start without it, see how it evolves. While you learn more about it, that's where you refactor, introduce design patterns, that's where you introduce abstractions. But that just concludes designing on changes. Design on changes it's worth to prepare for. It's a strategic decision. You have to make that decision. How do you think the system's going to change? And follow that. Okay? And then maybe slightly ignore those other parts. Maybe it's not worth to spend time on that. Just focus on your core. Okay? And as a homework, I want you to read more on principles of component coupling and cohesion. That can be found in Agile Principles by Bob. It's really worth, because what I was talking about here was more low level, based on class level, and that describes the same things on a component level. So how you could design your bundles to not talk to each other, how you could design your components to be decoupled from each other. Okay? And that's it for me today. Have you got any questions? No? No questions? Was it really so bad?
So basically, you said that if the decision how much abstract do you want to use when you start, how do you know that? It's like when you need to do, let's say, introduce interfaces, and where it's perfectly fine to use like class explicitly, because we don't like put interfaces everywhere, because in a week the client comes and we say, okay, we have interfaces and abstraction, but we cannot show you anything. So how do you know where is the line, how much abstraction you should introduce?
Well, abstraction should be introduced where you think the software is going to change. Right? So if your client is not sure whether he wants to work it one way or another, that's your hint. That might change, because he might change his mind, right? And but there's also another part to the story. If you're not sure what you're actually building, right? You can't make abstractions there, because that would be just too wasteful. Because that component is not stable. So abstraction should, that's actually one of those principles for component coupling and cohesion. You apply abstractions to stable components. Does it answer?
So it's perfectly fine sometimes? Hello? Okay, so very quickly, so basically sometimes you don't have the right requirements from, let's say, your clients, so sometimes it's just perfectly fine to do something small and simple, and then when the project evolves, then start to introduce.
Yeah, so the key is what you do when project evolves. When that component that you made simple and maybe took shortcuts, didn't do best design ever, what do you do in that moment? Do you just hack and add additional if statements just to handle that exception, or do you redesign and introduce proper abstractions? Oh, no.
Hi. I'm just thinking from a iterative development perspective here. Is it not reasonable to start by having your dependency on the class that you need, and the moment you need to come back to look at changing it, that would be a good time to introduce an abstraction?
Well, that's what I was trying to say, yes. But on the other hand, things like Doctrine or that bus browser pretty much know what's going to happen, I will introduce that abstraction from the beginning. Right. There's a few more questions.
Yeah, on the controller, I noticed you were injecting the request into the action, which I know is sort of Symfony sugar, but it's still an outward dependency. I just wondered, what your feelings were on that.
Could you repeat? Because I.
Yeah, sorry.
Yeah.
So the controller, you're injecting the request into the action.
Okay.
So that's still an outward dependency. I know it's Symfony sort of sugar, but because it's still an outward dependency, I just wondered how you felt about that.
Yeah, that depends how you treat your controllers. If that's something that belongs to Symfony or not. Because some people actually implement controllers that know nothing about Symfony. In that case, injecting requests is something that you shouldn't do. But Symfony can help you with that by param converters feature. So we can inject, instead of a request, you can convert a request to an object, which belongs to your domain rather than to a Symfony framework. So I actually prefer doing that rather than injecting the request. Does it answer your question?
Hey, basically when I'm thinking about the first question that was asked, I'm thinking like you sometimes have to fake it till you make it, and abstraction actually. What do you think? Is abstraction actually something that helps you to define what you need to learn more from the client? And sometimes you need to fake the repositories, you need to fake all sorts of things, and you kind of actually use the abstraction in that matter to learn about things you don't know or you need to find out more. So don't start with building the database before you actually need it.
Yeah, that's a good point. Wasn't a question, but very good point.
Hi, I've been implementing a domain-driven design on a website, and I keep wondering about the dependency injection. So ultimately, there's going to be a client who is actually going to create a reference of the objects you're going to inject to others. So where is going to be that client? For example, on the website, is that going to be the controller? Is it going to be resource?
Well, usually that's the container, isn't it? Service containers, you want to create that service for you.
But that's like using Symfony. If you're not using Symfony, how we're going to...
you can still use a container, right?
Right.
That container solves that problem of initializing your services. That's the solution.
Okay, we'll investigate that.
Also, one additional benefit of using container is that you actually decouple the way objects are created from the way they're used. So you can easily replace them, replace the way they're constructed, as long as the service conforms to the same interface. The client doesn't change. Does it answer your question?
Hi. When you constructed the controller in the Symfony framework, you put the templating engine and database in the constructor parameters. Do you now find that a habit you're doing because that's how you like to use Symfony, or do you consider it every time that you do that?
Actually, you can get away from, you don't have to use the templating, for example, directly. Because in Symfony, you can simply return an array and render a template implicitly, right? So you can actually get rid of that dependency. I think it's even better, right? Less dependencies on the controller. And then the same thing, instead of injecting doctrine directly, you can inject a repository or a service that uses the repository. And also we can get rid of the request, as I mentioned earlier. Does it answer your question?
Yeah, that's a useful insight, thanks.
Any more questions? I don't really see you, so. Okay, then thank you. And,